Hello everyone and welcome back to another tutorial on the channel The Power of Excel. So in this particular video we're going to introduce you to one of the important add-ins in Microsoft Excel by the name of Excel Solver, which can be used to model and solve different kinds of optimization problems in businesses. So the idea here is to introduce you to the interface of the tool in this tutorial and take up some of these optimization problems in our forthcoming videos. So let's get started.
Since Excel Solver is an add-in in Microsoft Excel, we first need to install this on our workbook, and then we can use it for optimization. To install this Excel Solver, we need to go to the Files menu, the Files tab, which is the very first tab. Go to Options. Under options, we have something called as add-ins in the left menu. Click on add-ins. Under add-ins, you'll see a list of different add-ins which are right now installed on in the Excel workbook, and the add-ins which are inactive. So these are the active add-ins right currently, and these are the add-ins which can be added to the workbook. So we need to go to Manage Excel add-ins, and to add an add-in, click on Go. Once you click on Go, you get a list of different add-ins which are available. It's Analysis Tool Pack VBA, Euro Currency Tools, and Solver add-in. And these are add-ins which can be used for different purposes. And one of them, that is the Analysis Tool Pack, is something we might be using. Both of these we might be using in our forthcoming tutorials, wherein we need to run some statistical analysis including hypothesis testing, linear regression, calculating descriptive statistics, and so on and so forth. So all of that would be used there. But for since our focus right now is on the solver add-in, we'll click on the checkbox next to the solver add-in and click on OK. So once you click on OK, you'll get this solver add-in under the data tab of your Excel workbook under the analyze group. So this is a group, the analyze group, and you'll find the solver add-in getting installed and visible here on the extreme right hand side on the data tab. So once you click on solver, you get the interface which is there for modeling and solving different kinds of optimization problems. This is the interface. This is how it looks like. And so there are a number of different solver parameters which needs to be entered before we optimize any model as per our requirement. So the very first parameter is the set objective, as you can see here. The set objective, this needs to be a cell or a set of cells having a formula for calculating something like profit margins or revenues or human resource requirements or durations, etc., which needs to be optimized. So in case something needs to be optimized, that needs to be selected under the set objective and by clicking on this button. So you can simply click on this button and select a cell which contains a formula for calculating any of these attributes. So that is a set objective parameter. The next parameter that we have is the to parameter. So depending upon the requirement, we can set the objective. For example, let's say we want to maximize profit margins. In that particular case, we select max in using this radio buttons, the radio buttons which are present next to the to parameter. So by default, if you open install Excel Solver for the first time, so by default, what is selected is the max option. So max is useful in case, as I mentioned, in case you want to maximize profit margins, revenues, let's say, or let's say, for example, sales, and so on and so forth. So whatever can be maximized or needs to be maximized can be optimized by making use of this max option. Then we have the min option, which is the minimization option in case something needs to be minimized. For example, we have losses, we have costs, we have labor, we have duration, which needs to be minimized, and so on and so forth. So any of these parameters, if there's a requirement to optimize by minimizing them, we can make use of this minimization option here. So this is the second option under this two parameter. The third under this two parameter is the value of. So value of is in case we're looking to achieve a specific value for the parameter which we have put under the set objective. So, for example, let's say we have put profit, we want to optimize the profit margins, and we want to achieve a minimum of a profit of $10,000, for example. So that is, we don't want to maximize or minimize, but we need to achieve a specific value. So, in case that is our requirement, we need to enter that value under the value of option under the two parameter. So that is what can be used in case we're looking at achieving a specific value, or we have a target value in mind for the objective function to be achieved. So that is the value of option. Then we have that by changing variable cells. By changing variable cells, these includes cells which contains variables to be changed to optimize the objective function. So whatever objective function we have set here uh, can be optimized by changing some of the variables which we have in our model, and we can include those variables under this by changing variable cells parameter. So we just need to click on this button and include the cells on our Excel workbook, which includes these changing variable cells. That is something we can do. So that is the third parameter that we are going to talk about. The fourth parameter that we have is the subject to the constraints. The subject to constraints basically includes all kinds of constraints which the objective function under which the objective function needs to be optimized. So whenever we optimize anything, we always have some constraints. We always have resources which are not available in plenty. So, in case we want to put specific constraints on our model for maximization, minimization, or the value of either of these three options, the value of options, so we can add these constraints here. So, Excel solver gives us six different types of constraints. One is the less than equal to constraint, where the upper limit is given. For example, the maximum inventory is given to us, or the maximum number of machines available are given to us, or let's say the maximum labor which is available is given to us. So if the availability is given, then we can make use of the less than equal to constraint from the solver, Excel solver. Then we have the equal to constraint, where a particular specific decision variable or set of variables have to be equated to a given value. So in those specific cases, we can make use of the equal to constraint. For example, let's say we want to say that the labor you the labor to be used for a specific product to be manufactured is cannot is all should always be equal to 10, for example. So in that particular case, in case something has to be equated, then we can make use of the equal to constraint. Then we have the greater than equal to constraint, where the lower limit is given to us. Let's say the minimum demand to be achieved is given to us, or the minimum revenue to be achieved is given to us. So those are specific examples where the greater than equal to constraint can be used in Excel solver. So if I show you these constraints, so these are the constraints which are available here. So less than equal to constraint, this is the less than equal to constraint. This is the equal to constraint. This is the greater than equal to constraint. The fourth constraint that we have is the integer constraint. That is, in case some of our decision variables which helps us to optimize a particular model, uh, are integers. For example, let's say we are calculating human resource requirements for a specific model, and in that case, the number of people is a variable. And so, in case we're looking at number of people as a variable, it needs to be integers and it cannot be decimal numbers. It cannot be 2.5, 3.7, 4.9, and so on and so forth. It has to be an integer. So, in case we want to put that kind of a constraint on our decision variables, then we can make use of the int constraint under the Excel solver. Then the fourth kind of the fifth kind of constraint that we have in Excel solver is the binary constraint. So that is required or used where the decision variables are of type yes, no, or true or false. So wherever decision has to be made, yes or no, true or false, those are the specific instances where this kind of a constraint can be used. And we'll soon have some tutorials on our channel where we'll be using the binary constraint as well. So that is the binary constraint. And the last constraint that we have is the difference constraint or the diff constraint. So the diff constraint is used where the difference between two variables or two or more variables is given to us, and we need to use that as a constraint. So in that those specific cases, we can make use of the difference constraint, the diff constraint. So these are the different types of constraints which are available. Now coming to selecting the solver method. So there are three different types of solver methods which can be used. Let me just cancel this to get to the main screen. So there are three different types of solver methods which can be used. You have simplex LP, which is there by default. You have the GRG nonlinear, and you have the evolutionary. So simplex LP is basically modeled around the simplex method under the linear programming technique. So all of you must have heard of the linear programming technique, which is a useful technique for solving linear problems involving some kind of maximization or minimization. So for doing that, we use this linear programming, and one of the techniques that we have under that a linear programming technique is one of the methods by which we can use optimize our models as the simplex method. That is why the name simplex LP here. So you can refer to the quantitative techniques books for getting to know what the simplex method is all about. And since if in case we need to run these models manually, it takes a lot of time and effort. And we'll see very soon in our forthcoming videos how we can use Excel to model and solve these problems within a few seconds. So that is simplex LP, specifically used for linear problems, wherever the relationship between the objective function and the changing cells is is the wherever the relationship is a linear one, that is in the form of a straight line. There we can make use of the simplex LP method. Now, talking about the second method that we have, that is the GRG nonlinear. The GRG nonlinear is specifically used in case the relationship between the objective function and the variable cells is a nonlinear one. That is, it is of degree 2 or greater than 2, right? So let's say there's a quadratic equation or there's a quadratic relationship between the objective and the variable cells, or greater than that, the degree is greater than equal to 2, therein we can make use of the GRG nonlinear. And we can also have some cases where we can use the evolutionary method as well. And we'll talk about this method as and when we have those tutorials on our channel, The Power of Excel. So these are the three different methods which can be used. And then the last solver parameter that we have is the options. So options are basically different, includes the optimization settings to be set before we run any optimization model uh, 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 for our case. So whether it is maximization or minimization, so this is the options window where we can set options specifically for all the methods together or for GRG nonlinear or evolutionary methods specifically. So as and when we actually get to these specific examples, we'll try and use the option, try and set the options as well. So that is a very basic introduction to this Excel solver in Microsoft Excel. And in our forthcoming videos, we'll be actually using these options, these parameters to solve different kinds of optimization problems. So I hope you liked watching this particular video. Thank you so much for your love and support, and we'll see you soon in our next video in a few days' time. Thank you so much and have a great day ahead. Thank you.